students and teachers who would be watching these videos. So before we start with our today's masterclass, let me just quickly introduce myself. This is Neha Chauhan here. I am a teacher expert at Cuemath with a teaching experience of more than 3 years. I've been teaching primarily mathematics and reasoning, and the regions that I cater to are India and US. Now we'll be quickly moving on to our masterclass. And before we start with that, please do get up yourself by grabbing a pen and a notebook so that you jot down the important points and concepts in our today's masterclass. Also, that you are able to solve the questions that we'll be working out in today's masterclass. So here we start with the first thing in our masterclass, which is to see what all are we going to cover in our today's live session. So these are the table of contents. We'll be understanding what measuring units are. We'll see what are their applications in our day-to-day life. What are some objectives? We'll be working on some interesting and engaging problems, both of basic level as well as of advanced level. And then we'll see what are the learning outcomes from today's masterclass. What are the takeaways from today's masterclass? So here we begin with the first thing, which is understanding the concept of measuring units. Now, as you have to teach this concept, and as we have to introduce this concept to children who are in grade 1 and in grade 2, children who are very, very young, the easiest way to start with it is some observations that they make from their surroundings. That is, instead of giving away the definition in the beginning itself, let's first try to build some observations to get some of their observations from their surroundings. That is, if you give a child a watermelon or something heavy to hold, and then if you give them something as a cotton ball, the observation which they would give you is that the watermelon was heavy, whereas the cotton ball was light. So there is what we have got is called as measuring. That is, they could measure not exactly how much the watermelon is heavy or how much exactly the cotton ball is lighter, but they could tell you that one is heavy and the other is lighter. They could get that comparison between the watermelon and the cotton ball. So heavy and light is what we got from their observations. Now comes in the picture comes measuring units. That is, we measure exactly what is the weight of the watermelon or what is the weight of the cotton ball. So when we exactly get the weights of these two different objects, we can compare it and we can even tell how much one is heavier than the other or by how much one is lighter than the other. So the quantity which is being spoken about here is the weight. Like this also, because these are children who are in grade 1 and grade 2, you can give them two different pencils. A pencil which has been used a lot, so it will definitely be shorter, and a pencil which is longer, which is the new one. So they would be able to tell you that one is longer, the other is shorter. But by how much one is longer or the other is shorter is what we cover in measuring units. And for that, we will need to measure the length of the longer pencil as well as the length of the shorter pencil, so that we can tell the longer pencil is how much longer than the shorter one, or the shorter pencil is how much shorter than the longer pencil. Now the difference here between this case and the previous case that we discussed of watermelon and the cotton ball is there the quantity or what we were discussing was about weights. Here what we are discussing about is lengths. So these different things have got different units in them, and there are also different units, larger units, smaller units, which children will learn definitely in higher grades. That is like a kilometer, a meter, a centimeter, a millimeter. These are different units exactly that we have in length. Like this we also have in weight, we have in time. There are different units which measure different quantities. It could be weight, it could be length, it could be time, and so many other things. It could be volume. So why did we need measuring units? So I have already given you examples of two cases that why do we need it. Like if we were to even further discuss why do we need it, I'll just give you a simple example. So let's say we have a foot. Let me just roughly draw a foot. This is a foot for which we need a shoe. Now I measure this foot and I say this is 5 long. Now I wouldn't exactly know whether it is 5 centimeters, 5 meters, which is not possible, but is it 5 millimeters, 5 centimeters, 5 inches, 5 meters, or what exactly it is? So the shopkeeper would not be able to provide me a shoe for this until and unless I tell them this 5 is what? How it could be, 5 could be anything. 5 could be a millimeter, could be a centimeter, could be inches. So I have to attach a unit to it because that unit is a standard length everywhere around the world. And we have standardized it so that for the entire world, it doesn't get confusing when you are trying to tell one length, when you're trying to communicate your ideas with respect to these quantities, which are being measured by, let's say, weight, length, time. So our time and their time should not have different units or should not have different values to it. When I say 5 inches, 5 inches around or across the globe is the exact same length. So with this, it becomes very easy for us. These are standard units. So it becomes very easy for me to find a 5-inch shoe anywhere in the world. And it will also be easier for the shopkeeper to give me such shoe. So quantity, when measured exactly how much is that, is what we call as measuring units. So let's see the definition of it. So it says a measurement unit is a standard quantity used to express a physical quantity. So that's what we have already discussed. We have also seen some real-time scenarios, real case scenarios like a pencil, a watermelon, and a cotton ball. We also saw a foot for which we need a shoe. And why do we need measuring units? And so these are all the applications. In our day-to-day life, we need measuring units. Now, another very good example is, like, let's say you come from market and you say that in a packet, you have tomatoes which weigh 5. Now, would that give you enough information? Because if I say in the packet, the tomatoes that we have weigh 5, would not give me an exact idea. It could be 5 grams, it could be 5 milligrams, it could be 5 kilograms. So we need to specify exactly how much does it weigh, and to be very specific, we need measuring units. So that when we communicate these quantities, we communicate them very effectively and very specifically so that the other person understands it as clearly as we say, and so that there is no confusion in there. And these are standard quantities, as I have already been mentioning. So 5 kgs around the world, across the globe, would be exact same. So now that we have seen or understood the concept of measuring units and its applications in our day-to-day life, we'll see what are objectives. We'll compare the lengths of given objects. We'll compare their weights, comparing money, and comparing time. So these are the quantities, the basic 4 quantities which we are going to discuss in today's masterclass. So let's go on to the next part. We'll start with comparing the lengths of given objects. So let's see. Here is what you see, some stacks, some differently colored stacks, and how would you compare them? Now, because these are all children who are in grade 1 and grade 2, the best way to tell them is that the start point of any 2 objects for which you're trying to measure their lengths and compare them, followed by measuring their lengths, always start with the same start point. As you would see in the first case, this stack in purple and this stack in green color, they all have the same start point. It's not above or below. They're on the same level. Now what happens is, because they are starting from the same level, the one which goes higher is the one which is lengthier. And so we can clearly say that the purple one is lengthier than the green one. But how much is the purple one lengthier than the green one is what we need to count. So we start counting the boxes. So here there are 1, 2, 3, 4, 5, 6, 7, 8, and this has got 6 blocks in it. So the stack is totally comprising of 6 blocks. So till here, the height was exact same. There are 2 more blocks in this stack. So this is 2 blocks lengthier than the green one. And that's why we put a symbol like this. The opening of the symbol is where it points to the greater quantity. The quantity which is greater will get the open side. The quantity which is lesser will get this closed side. So this is how we could compare. They should always start from the same level. Now, if you were to tell your children why exactly they should start from the same level, we can have from the different levels as well, but for it to become easier, a step easier, we can start from the same level. Just as if we are comparing the heights of different children, they're standing on the same ground. We don't usually ask them like one person would be standing on the floor, the other person standing on a chair or on a bench. They both stand on the same floor so that we can, just by looking at it, can tell who is taller or who is shorter. And to specifically know which child is taller or which child is shorter, we will need to get an inch tape or maybe a scale to measure that who is taller by the other one by how much. In the second case, you see that there are orange stacks and they both are equal, starting from the same point, ending at the same point, and each stack has got 5 blocks, so they are equal. That's why the symbol of equal to. In the third case, we see the first stack in maroon and the second stack in blue have got 6 and 8 blocks respectively. So clearly what we can see is the blue one is the longer one. And as we already have seen that, it doesn't say it is not 8, it is 1, 2, 3, 4, 5, 6, 7. Okay, so this is not 8 here. Instead, it is 7. And it is 1 block lengthier than the maroon one, because till here they both were same, 6 blocks each. So there is 1 extra block in the blue stack. So I hope all of you would have understood this concept of comparing the lengths of given objects, specifically for children who are in grade 1 and grade 2. Let's start from the same level to compare, because it becomes then easy for them to actually visualize it. And if it is only about telling which is longer, which is shorter, they can just look at it and they can tell which is longer and which is shorter. So with this, we move on to the next concept, which is comparing the weights of given objects. So what you see is a balance here, and then there are 2 trays on either sides, and they've got 2 objects. So now how does a balance work? A balance, when you have equal weights, objects which are equally heavy or are equally light, the balance would be in the same level. It will not be up or down. It will be on the same level. If it is, if the objects placed on either sides are like one is heavier, the other is lighter, the heavier will weigh down, will go down, the lighter will go up. And if you have, like the other way around, it's just that the same objects but placed the other way around, again the same thing. The one which is heavier will weigh down, the one which is the lighter one will weigh up, like will go up in the balance. Now, if it becomes confusing for your children to understand this, what you can give them the best example that they all must be really very, which they can relate to, is the seesaw in the park. Because they would be playing not always with the exact same weights child, like child who's got the exact same weight as them. Either the child would be a bit heavier or a bit lighter. So the one who is the heavier always, is touching the ground, is weighing down, and the one who's lighter goes up. And for the one who is a bit lighter has to put more pressure so that he gets the heavier one in the air. So seesaw is the best example. It also works on the same concept, on the same weighing property of the one who is heavier would weigh down, the one who is lighter would weigh up. And if they are of the same weight, the seesaw or the balance would not actually move much if you keep it balanced. Like if you do not disturb it externally, it would be on the same level until it is externally disturbed. So that's how it works. And as you all can see, the first case has got the watermelon and the pumpkin on either sides of on each tray. In the balance, the weight of watermelon is equal to the weight of pumpkin. In this, if you would see, the apple is going down and the orange is coming up. So the weight of apple is greater than the weight of the orange. And in the third case, the apple is going up and the bananas have gone down. So definitely bananas are heavier than the apple. Now we go to comparing money. So in comparing money, we basically be learning that, 1 rupee has how many paisa, or 1 paisa is what fraction of 1 rupee. So all you need to tell your child is that 1 single rupee, they would have definitely seen a 1 rupee coin. 1 rupee consists of 100 paisa. And if you were to consider 1 paisa, it is 1/100th of a rupee. It forms 1/100th part of a rupee. Like this, if we have 100 parts, that would put together make 1 rupee. So we've seen how to measure and compare lengths, weights, we've seen money, and then we come to time. Now this has a lot of things to discuss, time, because even children would know that we have, time, like elaborately if we discuss, we have a year, then we have months, then we have weeks, then we have a day, in a day we have hours, and then in hours we have minutes, and minutes then have seconds. So it starts as big as an year. So let's just see. So we're not starting, okay, so we'll start with number of days in a week. There are 7 days in a week. Then if you were to talk about a year, how many months do we have in a year? We have 12 months. Now these are some standard, some standard times that we have, like, 1 hour will always have 60 minutes. 1 minute is always 1/60th of an hour. 1 minute has got 60 seconds and a second has got 1/60th of a minute. So these are some standard conversions. Like if you want to convert from an hour to minutes, how would you convert it? And if you were to convert from a minute to an hour, how would you convert it? So these can be just taken down in your notebook, and as you practice, you don't have to memorize this. As you practice more and more questions on time, this by default will get registered in your mind, and you need not actually memorize this up. Now, when it comes, now that we have seen all the measuring units, though we are not talking about conversion, but as it says here, 1 minute is 1/60th of an hour, 1 second is 1/60th of a minute, and we had also seen that 1 paisa is 1/100th of a rupee. Now, a simple way to understand is that for a same quantity, that is, it could be weight, length, time, or it could be money. If you're going from a larger unit to a smaller unit, you were trying to convert that quantity from a larger unit to a smaller unit, smaller measuring unit, we always do multiplication. And when we are going from a smaller measuring unit to a bigger measuring unit, we would do division. So a paisa is 1 paisa is smaller than a rupee, than 1 rupee. So if you're going from 1 paisa to a rupee, you would do division, and that's how we get 1/100th of a rupee. Same way with a minute. 1 minute is definitely less than 1 hour, because an hour can accommodate 60 such minutes. So when we are going from a minute to an hour, we would do division. So remember, very, very basic, this is a very basic trick to remember. Going from a larger measuring unit to a smaller measuring unit, you would multiply. And when you're going from a smaller measuring unit to a bigger measuring unit, you would divide. So that's a trick to remember these things. So with this, we start with our questions. So we've started with comparing lengths. So you all can see a question on your screen which says, which rope is the longest? We have got 4 ropes here, X, Y, Z, and W. What we need to tell is that which one is the longest one. Now let's quickly see the examples, the options. So these are X, Y, Z, and W. Definitely we have to compare and tell which one is the longest. Now, as I had told you that for children, it is necessary that you place all your objects starting from the same point, so they any which ways have the same start point. And what we see is they also have the same end point. They're on the level on either sides. So it might initially look like that all the ropes are of equal length, but if you would look carefully, you would see that rope X has got more slacks or more curves in it. Then Y has very, very less, like the least amongst all. Then Z has some more slacks, but lesser than the slacks which we have in X. And then W has like a bit less than Z, but definitely more than Y. So slacks means the curves that we have in a rope. But when we are comparing, we should not have any slacks in the rope. It should be slack free. It should be completely taut. Taut in the sense that it should be completely be stretched so that it's not slacking from anywhere. There is no curve, no bending from anywhere. And if we would do that, the one with the more curves would elongate the maximum. That is, the rope X has got more curves in it, the more slats in it, so it will elongate the maximum. So the one which is the lengthiest is the rope X. So the answer to this question is option A. So I hope all of you would have understood this question. With this, we move on to our next question. Okay, so in the previous one, it is about the longest one. Here it is about which is the shortest one. So let's see our options. So we see that in each thread, the curves are of uniform curving. You know, it's not like that one curve is bigger, the other curve is smaller. They all are the same. So as I had said, if you would remember in the last question, the one which has got more curves is the one which is the longer one. The one which has got lesser curves is the one which is the shorter one. So if we would if you would just look at the four options, we can clearly say that option A has got lesser curves or lesser bendings. There are only 3. So this one would be the shortest one. Option A is the shortest thread here. So this is a very easy question. All you needed to know the fact that the lesser the slats, the lesser the curves, the lesser the bendings in a thread or in a rope or in anything, it will be shorter. If it has more, it will be longer. With this, we move on to next question, which is about comparing weights. We have already done length, so we are doing weights now. So which is the second heaviest fruit? We have 2 balances. Each balance has got 2 trays and then 2 fruits on them. The first one has got apple and a watermelon. The second one has got a watermelon and a mango. And we need to tell which is the second heaviest. So let's see the options. It says apple, mango, watermelon, and cannot be determined. So now let's quickly see. What we can say is that watermelon, I'll be writing it as W, from the first case is heavier than the apple. Now why do I say this is because we see that watermelon is weighing down apple, like it's going down, it's coming down, so it's heavier. Now same thing if we would apply in the second case, we can again say that watermelon is heavier than mango. So the heaviest here we can clearly say is the watermelon. But we do not know exactly the comparison between the apple and the mango because as watermelon was the heaviest among these 3 fruits, it would any which ways weigh down both apple and mango. But in between these 2, we do not know which is heavier. So we cannot determine this in this question. So the answer would be cannot be determined. Hoping that all of you would have understood this question, we move on to our next question. All of you who are already thorough with the concepts, you've already understood how to do it and you know the answers, please write your answers in the comment section. And if you have any questions, any doubts, do also put that in your comment section so that we're able to address and answer to those queries. Now it is again about the comparison of weights. It says which ball is the heaviest. So the first balance has got ball P and then 2 ball Qs. Then the second one has 1 ball Q and 1 ball R, 2 balls Q and R. Now let's see the options. Okay, so now we need to make some observations. What we see here is the balance is leveled. That it's not, one side is not up, the other side is not down. And we had already seen and discussed when it is completely balanced, what does it mean? That the weights on either sides are exactly the same, they are equal. So I can say that the weight of ball P is equal to 2 ball Qs. That is, if you have 2 ball Qs, 2 Q balls, they will be exactly the same weight as of a ball P. So this is first case. Coming to second case, we see that ball Q is heavier than ball R. And why? Because we see that it is weighing down R, it is going down, and R has gone up. So the lighter one goes up, the heavier one comes down. So Q is heavier than R. Now the question said which ball is the heaviest. So what we can see is Q could weigh down R. So it is heavier than R. So I can write it as Q is heavier than R. But when we see that even after putting two Q balls, it could still not weigh down P. It could only balance it. So P could accommodate two such Q balls in its weight. So we can definitely say that P is heavier than Q. So the heaviest one here is P. And if the question would have been to tell which is the lightest one, we would have said R. And if the question would have said which is the one which has got the medium weight or is in the middle of the two, we would have said ball Q. So as the question here is talking about the heaviest one, we know that the answer is option B. So with this, we would move on to our next question, which is comparing money. Okay, so question reads, dash is costlier than the ball and dash is cheaper than the toy plane. So we have the toys in front of us. We have a doll, a scooter, a football, and an aeroplane. The price tags have been written on each object. We need to compare them and we have to put them in the same order, just as we were putting the order for weights in the last question. We can actually start from the costliest one and going on to the cheapest one. So we can order it like that. But how do we order it? So before we get into ordering them, let's see what the options are. So these are our options. For those of you who already know the answer, can definitely put that in the comment section. So here we begin. The first observation here is all of them are three-digit numbers. That is, the price, the cost of each object is a three-digit number. So we'll write the place names. That is, ones, tens, hundreds, and would write the digits below these place names. So we write here 5, we write here 8, and we write here 4. And I'll tell you why are we doing this. Then for ball also we would do the same. So we have hundreds, tens, 1, it is 5 to 5. For scooter, again we write 100, tens, ones, so that is 4 to 5. And again 100, tens, ones, that is 5, 8, 5. Now children in grade 1 and grade 2 would have already started learning about abacus. So they know what are place names, place values, face values, and all of these things. As we need to compare, the numbers, which is basically the money, we need to compare the numbers. Now we cannot go into each, first compare doll and scooter, then compare doll and ball. So that will be very time consuming. We don't want it to be so time consuming because these are competitive exams and you need to be really very quick. So this is the shortest way. To compare, to find the costliest one, we would look at the digits at the highest place value, which is hundreds place in this question, because all of them have got 3 digits and the highest place value is a hundreds place. So we see in 2 cases at hundreds place we have 5 and 5, and in the rest we have 4 and 4. So we can definitely say that these 2 objects are costlier than scooter and aeroplane. That is, a doll and a ball is costlier than a scooter and an aeroplane. Now, if we were to compare between doll and football, as the digit at the hundreds place, that is the highest place value, is already same, we will go on to the next, the second highest place value, which is the tens place. So if we see, we have 8 here and here we have 2. We know that 8 is bigger or 8 is greater than 2. We get to know that doll is costlier than the football. So I can somewhere write it up here. We write here doll is costlier than the ball. Now we need to compare between that which comes at the third place, scooter or the aeroplane. So as we again see that the highest place value has got the same digits in both of them, 4 and 4. So we go on to the second highest place value, which is tens place. Here it is 2 and here it is 8. So 8 is bigger, it is greater. So then comes the aeroplane. So we write here plane. And then comes scooter. So what we know, the only object which is costlier than ball is doll. So here we would be writing doll. And is cheaper than the toy plane. The only object which is cheaper than the toy plane is the scooter. So we would write here scooter. So we need to get the options in the same order. It cannot be scooter and then doll. It has to be doll and then scooter. And what we see is that option B is exactly the same, and that becomes the correct answer to our question. So I hope all of you would have understood this question. So it's not just looking at the question that you can actually do it, because that would need a lot of comparison, and you might get somewhere confused if you're just doing it mentally. But if you would see, you need to know the concept of place names, place values, and then compare the digits and arrive at the correct answer. Hoping that all of you have understood this question, we move on to our next question, which is again on money. We have got two boxes in which we have Sneha's money in one and Ranjini's money in the second. It says, who has more money and by how much? So there are some coins given in each box. We have 1 rupee coin, 5 rupee coin, 2 rupee coin in each of these boxes. Maybe different in number, but these are the only 3 types of coin that we have. So I think all your children and students would have already seen these coins. They go to buy chocolates and all of other stuff. So 1 rupee coin, 2 rupee coin, and 5 rupee coin. Let's see the options. Okay, so we have to tell who has more money, that is first, and then we have to tell by how much more is their money. So we'll need to count definitely the money that they have. So easy way is to just count it. That's the only way. So we have 1, 2, 3, 4, 5, 6, 7 1 rupee coins. So I'll write 7 rupees here. Then this is 5 rupees, so I would write 5 rupees. This is, each coin is 2, so you would count 1, 2. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 rupees. Now we need to add them all together to get the total amount which Sneha has. So we know that 8 plus 7 is 15, 15 plus 5 is 20. So the total amount which Sneha has is 20 rupees with her. Now the same thing we need to do with Ranjini. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 8 rupees. This is 5 rupees. Now, because it's a 2 rupee coin, you'll count 1, 2, and you would go on like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So here we have 14. We need to add all of these 3 up. So 14 plus 8 is 22. 22 plus 5 is 27. So Ranjini has 27. So we can clearly see that 27 is a bigger number than 20. So Ranjini has more money. Now, if we were to find how much more money she has, we can just subtract Sneha's money from Ranjini's money. So if we would do the subtraction, 7 minus 0 is 7, 2 minus 2 is 0. So 7 more. And that we could actually, by looking at it, could also tell. But for those of students who cannot, you can go with the subtraction. By subtracting Sneha's money from Ranjini's money, we got the answer as 7. So she has got 7 rupee more than Sneha. And so the answer is option C. That is, Ranjini has got more money and she's got 7 more rupees than what Sneha has. With this, we have covered so far comparison of lengths, comparison of weights, comparison of money. Let's move on to our next type of question, which is comparing time. So the question says the hour hand of clock is dashed if the clock shows the time 7:45 p.m. So the question doesn't give away much. We do not know what to do here. So we'll have to look at the options. So these are the options. So it says the hour hand of the clock is either bit. Okay, so we have 4 options for the hour hand's position in the clock. It is between 7 and 8, closer to 8. It is exactly at 7, exactly at 8. Between 7 and 8 or closer to 7. Okay, so to answer this question, what we need to do is to first draw a rough clock here. I would draw this and let's mark the numbers so that it becomes easy for students to follow. So here comes 12, here comes 6, here comes 3, and here comes 9. Then we have 1, 2, here we have 4 and 5, we have 7 and 8, we have 9, then 10 and 11. And this is the center of your clock. Now, it is talking about the position of the hour hand. Now, what we know is that whenever a particular hour starts, the hour hand would be pointing at that exact number. That is, if we are starting with the 7th hour of the day, which is 7 a.m., it would be pointing at 7. So, and as we have something which is relatively saying 7:45 p.m., we would have our hand pointing at 7, the hour hand pointing at 7. Now, as we already know that there are 60 minutes in 1 hour. So 1 hour equals 60 minutes. So there will be there will be a minute hand as well. So once the minute hand has completed 60 minutes, or that is, you can say the seconds hand has completed its 60 minutes. That is, one round a second hand makes a second hand. A second hand, when it makes one complete circle, it gives you 1 minute. Like this, when it has done 60 minutes for you, then this hour hand would move from 7 to 8. Now, it doesn't mean that at the 7th hour, the hour hand was at digit or the number 7. In the middle, it did not move at all. And then straight away, when it completed 60 minutes, it moves to the number 8. It is not like that. It gradually moves. So the fastest moving hand is the second hand. The second fastest moving hand is the minute hand. The one which is the slowest is the hour hand. So that's why majority cases we do not observe the movement of the hour hand, but it keeps moving. When you are completing your 60 minutes, which is 1 hour, it will move from number 7 to number 8, or from any hour to any next hour. It will move from the number to the next consecutive, to the next number. So at the start of the hour, it was at 7. When it would complete half an hour, that is, the minute hand is pointing at 6, it will be exactly at the middle of 7 and 8. So half hour you're halfway through the hour, that would mean 7:30. And for this question, it would mean 7:30 p.m. Now 7:45 is definitely 15 minutes more than 7:30. So your hour hand would have definitely moved even ahead of this the mid bar that I have drawn here. So it would be somewhere here. So what we know now is when it is 7:45 p.m., the hour hand is between 7 and 8 for sure. It's not exactly at 7. And we have already seen that it will be right in the middle of 7 and 8 for 7:30 p.m., which is, when you're halfway through the hour. And as 7:45 p.m. is more than 7:30, it will be closer, it would have moved closer to 8. So we can say that the answer to this question is between 7 and 8, closer to 8. So that is the correct answer to our question. I hope this was a very concept oriented question. Also, what you need to know is the complete understanding of how a clock and the hour hand, the minute hand and the second hands work. So one key thing to remember is the fastest moving hand is the seconds hand, the second fastest is the minutes hand, and the slowest one, the one which moves the slowest, and that's why you're not able to recognize or to observe its movement, is the hours hand, and that's how it moves. So with this, we move on to our next question, and this is again on time. It says, which of the following clocks does not show the time less than 30 minutes past 3? So 30 minutes, we have not revealed the options yet, but 30 minutes past 3 would mean what? So now these are also some terminologies which you need to understand. What do we mean by quarter to 3, 15 minutes past 3, 30 minutes past 3, all of these things. So when we say quarter to 3, that means we are 15 minutes away from reaching to 3 o'clock. So that would mean 2:45. When we say 15 minutes past, quarter past, not exactly 15 minutes past, a quarter past 3 we mean 3:15 p.m. or 3:15 a.m. Because for these children who are very young, grade 1 and 2, we do not do 24-hour format. We do this 3 a.m. and 3 p.m. The number comes same. And then when we say 30 minutes past 3, the time that you're looking for is 3:30. It could be a.m. or it could be p.m., which is not specified here in the question. So now let's see what the options are. These are the options. Now we need to read the clocks in all the options and see or tell which of the following does not show time less than 30 minutes past 3. So if we would look at the option A, the hour hand is pointing at 3 and the minute hand is pointing at 12. So it is, the time here is 3. I'm not writing AM or PM because that's not specified in the question. Coming to option B, both the minute hand and the hour hand are pointing at 3. So it's 3:15. So this is how you tell, this is how you read out the time. And if you were to write it down, you would write it as 3:15 AM or PM. Option C is the hour hand is pointing at 4 and the minute hand is pointing at 12. So this is clearly 4 o'clock AM or PM. Coming to the option D, the hour hand is somewhere in between. It's not exactly at 4. If you would carefully observe it, it's not exactly at 4. It is somewhere between 3 and 4, and the minute hand is at 5. So the time here mostly is 3:25, 3 hour 25 minutes AM or PM. So we see that this is less than 3 hours 30 minutes. This is also less than 3 hours 30 minutes because it's just 15 minutes here, 3 hours 15 minutes. This is more than 3 hours 30 minutes because it's 4 hours, which is a bigger time quantity than 3 hours 30 minutes. And this is less than 30 minutes because 30 minutes, and if you would compare 25 minutes, 25 minutes is lesser than 30 minutes. So the correct answer to your option is option C, which is not less than 3 hours 30 minutes. It's more than that. And how much more if you were to tell? It is 30 minutes more, because if you would add 30 more minutes here, that these two 30 and 30 minutes would comprise 60 minutes, which would give you 1 hour. So you can add another hour here, and that would be 4 hours. That's how you get. So it's 30 minutes more than 3 hours 30 minutes. I hope all of you would have understood this question. With this, we move on to some advanced level questions here, and let's quickly see. So it says here, B and E is longer than B and D by how many units? Each box here in the grid that you see on your screen stands for 1 unit. So let's see the options. These are the options that we have. So we'll first go in with B, and B has been given as a single bar. But on top of it, if you would see, there are boxes, and each box in the grid stands for 1 unit. So let's see how many box or how many units is B. So it's 1, 2, 3, 4, 5, 6. Then B and E was the first, so we'll go in with E. So 1, 2, 3, 4, 5, 6, 7, and 8. So if we were to write B and D put together, it is 6 plus 8, which is equal to 14. Now we'll go in with B and D next. We had already counted B, which is 6 units. We'll write just here units. Okay. Yeah, so B was already 6 units. Now we need to count how many units in D. So it's 1, 2, 3, 4. So we write B, oh, this is E. This is E here. B and D here equals 6 plus 4, which is 10 units. So they have already said that B and E is longer. B and E put together is longer than B and D. But what we need to find is how much it is longer than B and D put together. So all we need to do is subtraction here. 4 minus 0 gives us 4. 1 minus 1 gives us 0. We need not write that. So 4 units. It is 4 units longer than B and D. That is, if you would put the bars B and E together, they are 4 units longer than bars B and D put together. So the correct answer to this question is option D. With this, we move on to our next advanced level question. Okay, so it's something related to time, but now it's not like hours, minutes, seconds, and so it is mostly like a calendar that you see on your screen. It says, if Tarun's birthday is on the third Saturday of September 20 some year, on which date Tarun will celebrate his birthday? So, okay, so let's quickly see the questions, the options here. We have 4th September, 11th September, 25th September, and 17th September as the answer, as the options. So, what you need to know is, or what the child needs to be really very thorough with, is the order in which the days come in a month. That is, we start with a Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Now, why I say this is because if you would see, they have just written the initials of each day, which is M, T, W, T, F, S. Now, there are some initials which are repeating themselves twice. If you would see T and T, S and S. So, this is very obvious to us, but, it might get confusing for children who are in grade 1 and grade 2. By looking at this, they might get confused and they may forget the order in which the days come in a week. So you need to be very particular about this, and you need to ensure that your child or your student knows the sequence of the days in a week very, very thoroughly. That is, we start with a Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Because here it is S and S, they might get confused between which is a Saturday and which is a Sunday. So what we know is, in a week, Saturday comes first and then comes Sunday. And how you can tell them is that every week that they go to school, Sunday is the day wherein they get an off. So you go to school for 6 days, and the 7th day is the day wherein you get an off. So the last one is the Sunday. The one which comes prior to that is Saturday. So the first date which falls on a Saturday is your first Saturday. The second date that falls on a Saturday is your second Saturday. So this is our first Saturday, this is our second Saturday, and this is our third Saturday. And we needed to know which is the third Saturday because the question says Tarun's birthday is on the third Saturday. So the correct answer to this question becomes option D, which is 17th September. So I hope you all are clear with this question. The key thing here to know is that your children must be really very thorough with the sequence of the days in a week, and that would ease out the question completely. With this, we move on to our next part, which is the learning outcomes, to see what all we have learned in today's masterclass. So what we know is that we let the children explore, that is, from their surroundings. There are so many things that you can give examples. I listed only a few, like pencils, watermelon, cotton balls, seesaw, and so the money. Because children these days are very smart. They go to buy things. They know that things come with a certain price tag, how to compare it. So let the child explore a lot of things which are more relatable instead of just being very textual. Because if they observe things around them, they would get more observational skills and they would retain those concepts for a longer time. And so as I said, understand what they observe and then appreciate, so that once you see that they have already observed a lot of things related to the concept, you can then build on that concept. Because if you have nowhere to start from and you're just trying to build on the concepts, it will not be strong. The foundation will not be strong. So you need them to know, why are we doing this concept and why is it more important and how is it more relatable and why do we need to learn it? Because you go to shop, you need to know which pen is costlier, which is cheaper. If you want to buy the costlier one or the cheaper one. If you're going to a vegetable shop, you need to know that how much does your vegetable or how much does your fruit weigh. And if you're going to a footwear shop, you need to know how do lengths work. So these are some real life examples wherein all of these things are directly applied, and measuring units is which is majorly and widely applied. You have a lot of examples to give to your children. So with this, we almost have come towards the end of today's masterclass. As you all can know that we've already launched our TUCO 2020. TUCO stands for the Ultimate Cuemath Olympiad. All of you who are really wishing to get your child enrolled for this Olympiad, so that they get an exposure of how competitive exams are right from the beginning of their education, please do register yourself. the details of which we would be discussing towards the end of this video. So do stay tuned, do listen to that so that you can you are able to hassle-free register for TUCO 2020. So as we all saw in today's masterclass, how logical reasoning inculcates the ability to think logically in a child, they start thinking in an innovative manner. They also strive to get to the answer in the shortest possible way. And this is exactly how a student gets trained by a Cuemath expert, and all of it is being provided in Olympiad masterclasses by Cuemath. So with this, I would like to introduce the TUCO registration forms. Every student who wishes to take up the real-time Olympiad examination by Cuemath, please go ahead and click on the link given in the description box below. The registration amount for TUCO is Rs 200 only, and the benefits that you get on registering for TUCO is that you get a complete course curriculum to prepare for it, which is worth Rs 5,000. So every time we have a masterclass, an Olympiad masterclass as we had today, which is scheduled, you can join us there and then later can work on extensive sheets on the same topic through the course curriculum provided when you register for TUCO. So make sure you do not delay and register yourself to get the most out of the curriculum worth Rs 5,000 just for Rs 200. And with this, we'll be winding up today's